What's up, everybody? This is Danny Mathematics here with another example to explore. And today, guys, I want to go over example 1 and example 2 of how to successfully write scientific notations. Okay, scientific notations. Now, a scientific notation is just these particular examples, right? Where you have a number that's times 10 to a certain power. And that certain power will dictate the direction of the decimal, okay? Because a scientific notation is just a shorter version of writing a more complex number, okay? It's just a shorter, more simplified version of writing a more complex number, all right? And once again, the exponents will let us know how many times we need to move the decimal point of the number either to the right or to the left. Now, in example 1, as you can see, the exponent is a positive. It's a positive 5. So whenever you have an exponent or a power, either we call these exponents a power, same thing. Whenever you have an exponent or a power and it's positive, then we must move the decimal point to the right. Because this is positive, this actually represents a way bigger number than 4.56, okay? It might be 4 million or something, right? This represents a way bigger number, and I know because the exponent or the power of the exponent is positive. Okay, it's positive, meaning that we're going to move that decimal how many times to the right that the exponent or the power states. Okay, now in this particular example, guys, example 2, if you notice, we have a negative exponent. Whenever we have a negative exponent, guys, that means that this number is actually a decimal. It's actually a very, very small number, so small to where it's actually a decimal. Okay, so when the exponent or power is negative, we move the decimal point to the left. So remember, guys, if we move the decimal point to the right, it's because the exponent is positive, meaning that this represents a much bigger number. If we move it to the left, that means that the exponent is negative, and this value or this expression represents a much smaller number, so small to where it's actually a decimal. Okay? So let me go ahead and show y'all real quick, guys. And if you understand that, guys, scientific notation is very easy, okay? So let me just go ahead and rewrite it. I have 4.56 times 10 to the 5th power. All right, times 10 to the 5th power, okay? Times 10 to the, it's already up here, all right? So once again, times 10 to the 5th power. What that means is, since it's positive, we must move the decimal 5 times, or 5 place values to the right, okay? So let's actually do that. 1, 2, 3, 4, 5. So now the decimal would land right there, okay? Once again, 1, 2, 3, 4, 5. So I move 5 units to the right, okay? Now, I have to fill in these particular slots with zeros, okay? Because they're empty, I must fill them in with zeros, okay? So, the number that this whole expression, scientific notation, represents is actually 456, and this is a comma, 1,000. Because once again, the decimal is right here. I moved it 5 times to the right, meaning that I had to add or attach 3 more zeros to the number, okay? So 4.56 times 10 to the 5th power is actually 456,000. That's the actual number that this represents, okay? All right, so that's the answer to this one. All right, now let's try the next one, right? I'm gonna go ahead and write it. I have 9.84 times 10 to the negative 3rd power, all right? So I'm just gonna write 9.84. All right, now, remember, guys, because it's negative, I must go 3 spaces or 3 place values to the left, okay? I must go 3 place values to the left because the exponent is negative, Okay, here the exponent was positive. I went to the right. Here is negative, I go to the left. All right? And let me also just write it right here. So if you are copying this down or doing it yourself, you have your notes or the notes that I put. All right, so I'm gonna do the same thing as I did here. It's just that I'm going in the opposite direction due to the negative exponent. All right, so let's go ahead and do that. I only need to move 3 times to the left this time. 1, 2, 3. Now, the decimal point would actually be right here in this area, okay? So 9 already took the first slot, but the next 2 slots, I must fill it in with zeros. Just like that. So now our final answer is 0.00984. That's our answer, guys. 0.00984. Okay? So 9.84 times 10 to the negative third power is actually 0.00984. That's the actual value that this scientific notation represents. Okay? So those are 2 great examples, guys, of how to successfully write out the actual number that's represented by a scientific notation, or to find the number that is represented by a scientific notation. Thank y'all so much, guys, for tuning in. Talk to y'all next time.